Honors Geometry, Unit 4, Day 2, Notes. We'll start right off with this lovely little graphic that gives you some quadrilaterals. Many of these you will need to know. There's a couple extra in there that you won't need to know the dart or the kite. Even though kites are not an uncommon quadrilateral. Many of you have flown kites when you were younger, or maybe even recently. And a kite, as you can see by the markings, has a set of consecutive sides that are congruent, and then a second set of consecutive sides that are congruent. That's the definition of the kite. Two sets of consecutive sides are congruent, which then gives you some cool stuff like you have one set of opposite angles that are congruent, and the diagonals are perpendicular. They form a right angle. But we're not going to talk much about kites. We're going to talk about it all for the rest of this this particular lesson. All right. So the ones that we will be talking about: a parallelogram. That's the big one. Okay? We're going to be talking a lot about parallelograms in Unit 4. And just like the word itself has parallel in it, and that's the main aspect of the parallelograms that drives everything. And that is, you have two sets of sides that are parallel. Okay? Two sets of opposite sides are parallel. So, this side is parallel to this side, and this side is parallel to this side. Right? And because of the two sets of opposite sides being parallel, now we've got, back in Unit 2, we have, two parallel lines crossed by a transversal. Oh, look, we know something about this angle and this angle. Right? They're consecutive interior angles. They add up to 180. It's not that they're congruent. They don't have to be unless it's 90 and 90, but they do have to add up to 180. They're supplementary. Right? And then when you add the second parallel line in, right, you end up getting, this guy and this guy are supplementary. And if you use the transitive property that says, this angle adds up to 180 with this angle, but this guy adds up to 180 with this angle as well. Well, since this one and this one add up to 180 with the same angle, those opposite angles have to be congruent. Okay? Now, if you didn't follow what I just said, you can either rewind it and slow it down, or you can just remember that opposite angles are congruent in a parallelogram. Okay? That's why these are colored blue. These guys are colored green. Opposite angles are congruent. And then the markings that they've already included, opposite sides, are also congruent. Now, do all four sides have to be congruent for a parallelogram? No, they don't. Could they be? Yes, because if all four were congruent, then those two would be congruent, and those two would be congruent, and it would be true. You would just have a special type of a parallelogram. And what type of a parallelogram would that be? That would be this guy, a rhombus. Rhombus simply has four congruent sides. It is a parallelogram. Okay? It is a parallelogram. It's a special type of a parallelogram. So every rhombus is a parallelogram, but only a parallelogram that has four congruent sides will be a rhombus. Well, what if it wasn't the four congruent sides? What if it were the four congruent angles in a parallelogram? Well, four congruent angles in a parallelogram would give you your good friend, the rectangle. Be 4 90-degree angles. And then what if all four sides were congruent, making it a rhombus, and all four angles are congruent, making it a rectangle? If it's both of them, Guess what? It's a square. So the rhombus, the rectangle, and the square are all special types of parallelograms. Okay? They all fall under the parallelogram family. The ones that do not fall under the parallelogram family are all these other guys, but mainly we're going to look at the trapezoid. So why isn't a trapezoid a parallelogram? Okay? The definition of a parallelogram is a quadrilateral with two sets of opposite sides that are parallel. By the way, don't say there are 4 sides that are parallel, because that would be 4 sides that are parallel. Okay? And that's not a quadrilateral. Okay, now here's a trapezoid. How many opposite sides are parallel? Well, these two are opposite sides and they're parallel, but those two are not. So the main thing that makes a trapezoid is there is one set of parallel sides. There's only one set of parallel sides. Okay, you get to the isosceles trapezoid, obviously it's the same thing because it is a trapezoid. You got one set of sides that is parallel, and then the other pair of sides not parallel. Okay, so that means that a trapezoid is never a parallelogram, and a parallelogram is never a trapezoid. Okay, so that should be enough information to help us to identify parallelograms, rectangles, and squares. So let's pop down to this first topic and let's answer some questions. So identifying parallelograms, rectangles, and squares. This question gives you 3 figures, figures A, B, and C. And we're going to look at these questions. Which figures are parallelograms? Okay, remember parallelograms have 2 sets of opposite sides that are parallel. I don't see any parallel arrows anywhere. So I'm not going to assume that we have 2 sets of opposite parallel sides. But what I will look at is the fact that they gave me measurements. Okay? So if you look up the page here, notice that opposite sides are congruent to each other. Okay? These sides are congruent. So figure A, are those congruent? Yes. Are those congruent? Yes. You have 2 sets of opposite sides congruent. That is a parallelogram. Figure B, is this set of opposite sides congruent? Yes. Is this set of opposite sides congruent? Yes. So figure B is a parallelogram. How else could I have looked at that? I also have these 90-degree angles. You could have said opposite angles are congruent. These opposite angles are congruent. That's another way to show that a quadrilateral is a parallelogram. 2 sets of opposite angles are congruent. Like this one, same thing. 2 sets of opposite angles as well as sides, congruent. And now for C. Opposite sides are congruent? Yes. Other opposite sides are congruent? Yes. So all 3 of them are parallelograms right off the bat. So if they're parallelograms, they might be a rhombus, a rectangle, a square, okay, because those are all types of parallelograms. So now it asks, which of these are squares? Well, hopefully you know that squares have 4 congruent sides and 4 congruent angles. So let's look. 3, 3, 3, 3. 4 congruent sides. Check. That makes it a rhombus, by the way. 1, 2. 4 congruent angles. So it has both. That's a square. Figure B has 4 congruent angles, but not all the sides are congruent. So no, figure B is not a square. Figure C doesn't have 4 congruent sides and it doesn't say that these are right angles. So definitely not a square. So only figure A. Rectangles. A rectangle must have 4 right angles. Right? Must have 4 right angles. It's a parallelogram where all the angles are congruent. So, is that a rectangle? Sure is. Okay? It's got 4 right angles. So it is a rectangle. How about figure B? Yup, it is. It's a rectangle. There's no right angles here, so it's only A and B. Okay, so remember, a square is a special rectangle. So anytime you say something's a square, it's always going to be a rectangle. Right? Moving on. Properties of quadrilaterals. Okay, some of this we don't need to talk a whole lot more about. We'll just do, and then let's just get through it here, shall we? So a trapezoid. Only one pair of parallel sides. That is the definition of a trapezoid, folks. That's exactly what it is. 2 pairs of parallel sides. Well, if it only has 1 pair, it can't be 2 pair. All the sides are congruent. Can't happen for a trapezoid because when you have, these guys going in, it's making one of those parallel sides shorter than the other one. So no, you can't have all sides congruent, and you can also, because of the slants, you can't have 4 right angles. So that's it for trapezoid. Okay, parallelogram. Right? A parallelogram, by definition, has 2 pairs of parallel sides. Okay. Must it be true that all sides are congruent? No, you have to have opposite sides congruent for a parallelogram, but you don't have to have all 4 of them congruent. How about right angles? Again, no. Opposite angles must be congruent, but all 4 don't have to be congruent to be a parallelogram. If all 4 are congruent, yes, it is a parallelogram, but that's only because it makes the opposite angles congruent. Then finally, rectangle. Well, a rectangle is a parallelogram, so you have to say it has 2 pairs of parallel sides. Does a rectangle need all sides congruent? No. Does it need 4 right angles? Yes, that is a rectangle. So hopefully you're good there. Okay, let's move on. True or false? Now I gave this little family tree here, right? That goes from the broadest down to the most specific. It's kind of like saying, mammals, all the way down to, pug dogs, okay? Mammals, and then you can get down to, just dogs in general, and then you get down to pugs, okay? You're getting more and more specific, right? If all you know is that a polygon has 4 sides, it's a quadrilateral. That's it. It could be convex, it can be concave, it could be a trapezoid, it could be a kite, it could be parallelogram, rhombus, whatever. If it's got 4 sides and it's a polygon, it's quadrilateral. So quadrilateral could be one of these 3 things as well. And then, if it's a parallelogram, it might be a rhombus or a rectangle. And if it's both, it's a square. If it's a trapezoid, the only thing that it could be more specifically is an isosceles trapezoid, where the non-parallel sides, which we call the legs, are congruent to each other. Okay, so let's look at this true-false set of questions. Every quadrilateral is a square. There's a quadrilateral, a square. Nope. False. Every square is a parallelogram. So this square does happen to meet all of the requirements of being a parallelogram. 2 sets of opposite sides are parallel. Then yes, it is a parallelogram. It's like saying the pug is a mammal. Sure, absolutely. So every square is a parallelogram. True. Every parallelogram is a square. So this is like Unit 2 converse. If a figure is a square, then it is a parallelogram. We said true. If a figure is a parallelogram, then it must be a square. Well, no, there are parallelograms that don't have 4 right angles and they don't have 4 congruent sides, so that's false. The converse was false. Every rhombus with 4 right angles. So if a rhombus has 4 right angles, then it is a square. True or false? Well, look at a rhombus. Rhombus has 4 congruent sides, remember? So if it happens to have 4 right angles, like this question says, if it has 4 right angles, it's a rectangle. So if it's a rhombus and a rectangle, you better believe that is a square. That's true. Okay. All right. So we looked at sides and angles. Okay. Now just a little bit about diagonals. Okay. In a parallelogram, diagonals, 2 things. Number 1, we've already mentioned, we're talking about parallel lines and now with transversals. So we know that alternate interior angles are congruent. We also know that consecutive interior angles, which are formed by 2 parallel lines and one of the sides, these guys add up to 180. But if you draw the diagonal, if you draw a diagonal with those 2 parallel lines, you get some alternate interior angles. And we know from Unit 3 that if you have 2 parallel lines, then alternate interior angles that are formed got to be congruent. So we know that. The other thing that's kind of interesting, I don't think this question is going to ask us about it, but check this out. Parallelogram diagonals bisect each other. So that means that this diagonal got cut in half and the other diagonal got cut in half. Now, are all 4 halves congruent? Not necessarily, only if it's a rectangle where the sides aren't slanted and you got 90-degree angles. But they cut each other in half. All right, so there's a little extra info for you. You might want to write that down somewhere. So let's look at this particular question. Use the given information in the figure to find the measure of angle A. So measure of angle A. The value of X. And the measure of angle ABD. So ABD. So that angle would be this guy right here. So let me just do this for ABD. And yes, I'll put the X back there. Okay, so one at a time. Angle A. Angle A is a full angle inside of the parallelogram. It's one of the 4 original angles. You had angle A, angle B, C, and D before they put that diagonal in there. What do we know about these angles? We know that consecutive angles are going to add up to 180. They're supplementary. We also know that opposite angles are congruent. And lo and behold, they gave you that angle C is 104 degrees. So because angle C is 104 degrees, the measure of angle A is 104 degrees. Okay. This next one I think is the easiest one. That's finding X. It's a side. The only thing you know about parallelogram sides, opposite sides are parallel, which has nothing to do with how long they are, and opposite sides are congruent. So that means that this side must be congruent to this side, which means that 2x must equal 2. So if 2x equals 2, divide by 2, and you get x equals 1. Told you that was simple. And then finally, They asked us for this angle right here. Okay, the green one. All right, well, the green one, you could say that it's alternate interior with this guy right here. Right? Two parallel lines crossed by a transversal, alternate interior angles are congruent. So if I find one of those green angles, I found the other green angle. Well, look at this. Here's a triangle, and we know that triangles have an interior angle sum of 180 degrees. So in that triangle, we have a 104 and we have a 42, which add up to 146. So you simply take 180, subtract 146, and you've got 34 degrees. So that is angle BDC, which is congruent to angle ABD. So to measure angle ABD is 34 degrees. Okay, looking good. Let's move. Let's move right along here. Conditions for parallelograms. Okay, so we just went through some things where we said, if this is a parallelogram, then these things are true. Now let's find the converse. If this is true, then this is a parallelogram. So the things that you could have, okay, ways to prove that you have a parallelogram. Okay. Well, the first way is, I think, the most obvious way, and that is the definition of parallelogram. You have to know that you have two sets of parallel sides. If I put parallel, parallel, and parallel, parallel, the signs, those markings prove that I have a parallelogram. If I have two sets of opposite sides that are congruent, that's enough information to prove I have a parallelogram. 17 meters, 17 meters, 14 meters, 14 meters. It's a parallelogram. Two sets of opposite sides are parallel, are congruent. So we could have the parallel or the opposite if you're talking about two sets of opposite sides. Okay. Next thing we could have is two sets of opposite angles are congruent. Two sets of opposite angles are congruent, right? And then the last one, I don't see it in this picture, but just in case, if the two diagonals bisect each other, okay, those four conditions will give you enough proof to say that you have a parallelogram. Now there's one more. If I have one set of opposite sides that is both congruent and parallel to each other, that is the fifth and final way to prove that you have a parallelogram. If I have a four-sided figure, a quadrilateral, that has any of these five conditions, or I can get to those five conditions with the picture, then I have proven that I have a parallelogram. All right? So let's look at these, not necessarily in order here. Let's take what I think would be the easiest ones. Right? I think this is the easiest one right here, because angle H and angle I are opposite angles and they're congruent. Angle J and angle G are opposite angles, and they're congruent. So right there, I have two sets of opposite angles are congruent. That is enough information to prove that it has to be a parallelogram. This guy, I think, is pretty straightforward. Here it's talking about PQ and RS. Those are the only two sides that have any markings. So that's one set of opposite sides. They both have the arrow saying they're parallel, and they both have a congruent slash saying that they are congruent. So because one set of opposite sides is both parallel and congruent, I can say that has to be a parallelogram. I have proven that it's a parallelogram. Okay, so now let's look at, let's go with the first one, because I think both of these two take just a little bit of work. Okay, you say, well, there's one diagonal and it doesn't have anything with congruent marks here, so diagonals bisect each other doesn't work because I don't have there we go. That would be diagonals bisect each other. So I can't use that to prove that this ABDC is a parallelogram. What do I have? Well, I've got one angle mark on BCD and one angle mark on ABC. Well, if you remember some of your proofs and some of those questions from Unit 2. Okay? When we did those proofs, the very short 2-line proofs, we ended up saying if alternate interior angles are congruent, then you have proven you have two parallel lines. So if those two particular angles are congruent, that means that those lines are parallel. So because of the markings they did give me, I can now write in that those are parallel because of the alternate interior angles. So that's great, but I would need two sets of parallel lines or parallel sides to prove that this is a parallelogram. Okay, well, what about the double angle mark here and the double angle mark here? Well, those are alternate interior angles if you use those two sides. So if those alternate interior angles are congruent, then my lines are parallel. So because I've got two sets of parallel sides, yes, that does have to be a parallelogram. Okay, let's look at this last guy right here. We've got one set of parallel sides given to you. You say, well, it doesn't have the other set, so I guess that's a not necessarily. Well, not necessarily, not necessarily. Because there is more marking. So we at least have to look at it. Well, look at this. It's alternate interior angles again. Okay, so be careful on this. This is about as tricky as Alex can give you. Which two sides with that gray transversal created those two gray angles? Well, that would be this side and this side. They created those two angles, right? Okay. So because of those two angles, you can say that those two sides are parallel. Well, the only problem is they already said those two sides are parallel. In order to get these two sides parallel, you would need this angle and that angle, and we don't have them. So all you can prove is one set of parallel sides. So this may not be a parallelogram. So it's not necessarily a parallelogram. Okay, I believe that's all. Oh, you got a little bit more. Cool. All right, can never get enough of a good thing, especially geometry. All right, finding measures involving diagonals of rectangles. So I mentioned that in all parallelograms, if this is a parallelogram, then the diagonals cut each other into two congruent halves, okay? Now, what if we started with a rectangle And the rectangle has 90-degree angles, so guess what? Because the rectangle has 90-degree angles, there's no slant to make the diagonal longer. Well, that means that those diagonals are congruent in a rectangle. If you've got 90-degree angles, your diagonals are congruent, okay? I want to write that down. If you have 90-degree angles, they're all 90 degrees, then the diagonals have to be congruent. So if these got cut in half and these got cut in half, all four of these little pieces are congruent for rectangles, okay? If it's just a parallelogram, then they're bisected, but they're not congruent before they're bisected. Okay, so that is the information you're going to need for this next question here. Okay, so it says Jn is 2x plus 8. So Jn, I'll just color code it here. Jn is 2x plus 8. Ln is 5x plus 2. Okay, that's nice. And then it says the measure of angle JNM, which is this guy right here, JNM, this angle. So I'll put this right in here just to show that I get my angle. That angle is 54 degrees. Okay. So we've got us a rectangle. Even if this were not a rectangle, if they just said this is a parallelogram, we could at least find x, and therefore we'll know they're asking for km. Okay? We could at least find x here, right? So I want to find x first. What is the relation between the gray segment and the red segment? Well, remember, these diagonals bisect each other. So that means that Jn is congruent to Ln, or segment Jn has a measure that's equal to segment Ln's measure. Well, what were the measures? Well, it was 2x plus 8 must be equal to 5x plus 2. Now we're back in Algebra 1. Okay, fun. I'm going to subtract 2x. So I've got positive 8 equals 3x plus 2. I'm going to subtract 2. Okay. Divide by 3. So I know that x is equal to 2. Well, that's good. That's very good. But, they're not asking us for x. They're asking us for the length of km. Km is this entire diagonal. Well, let's start putting the x back in where we know. If I put it in here for Jn, I know that Jn equals 2 times x plus 8, and x is 2. So I'm going to put my 2 there. Red 2. Okay. So Jn equals 4 plus 8, which is 12 units. Ln, hopefully we know what Ln is. Okay. 5 times x plus 2. Well, again, x is 2, which tells me that Ln is also 12 units, which makes sense because Ln and Jn had to be congruent. So what's the relationship between Km, an entire rectangle diagonal, and Jn or Ln, which are half of a rectangle's whole diagonal? Well, if I take the 12 and the 12, I know that JL is going to be 24 by the segment addition postulate. Jn plus Ln equals JL. Well, 24 is going to be Km as well. Okay. Why is that? Because, as I said, if you have right angles, which a rectangle has, then the diagonals are going to be congruent. So if we know JL is 24, we know KM is 24. Okay? So I know that all of these little pieces are going to be 12 units long. All of them. Okay? Every single one. All right, now that's going to help us a little bit here to do our last thing, and that is to find angle NKL. So angle NKL, let's see, angle NKL, let's color it black here. NKL is this guy right here. Okay, now there's a bunch of ways we could go from the only angle they gave us, which is here. So this angle is 54. Okay. We got to go from there to the black angle. Okay, so I'll just pick one way and show it to you, and if you come up with a different way, great. You can tell me about it in class. But I'm going to use vertical angles first. Right? I'm going to erase the side lengths because I don't care how big the sides are when we're talking angles, other than the fact that I know that they were all congruent. I knew they were all 12. Right? So I know that if this is 54, then this guy is 54. Okay, now go back to the previous unit, and I want you to remember this. If I have, by the way, these are all congruent, remember. If I have an isosceles triangle, that means two sides are congruent. Congruent sides are opposite congruent angles. So I know that this angle and that angle are congruent. So that means that 54 degrees plus two congruent angles is going to give me 180 for this triangle. Okay. So I'm simply going to take 180, I'm going to subtract 54, get 126, and then because both of these angles are congruent, I'm going to divide it by 2, and I get 63 degrees for the measure of angle NKL. Okay? NKL is 63 degrees. Okay? I'm going to erase this and we'll do this next question. Okay, so we got all that erased, and I blew this up a little bit for you. All right, diagonals of a rhombus are kind of fun. Okay? Now, as I mentioned before, when we were talking about a rectangle, and this is true for a square too because they're 90-degree angles. If we got 90-degree angles everywhere, then because the sides are not slanted, the orange is congruent to the green. And then since these are cut in half, all four of these are congruent. So the rectangle's diagonals are pretty cool too, but the rhombus diagonals, those are my favorite. Because they are slanted sides, that means that one diagonal can be longer than the other. The only time they're not is when this happens to be 90 degrees all around, so it would be not a rhombus by itself, but it would also be a square, okay? But like this diagonal definitely appears to be shorter than this diagonal, okay? So if that's not a square and it's just a rhombus, one diagonal is longer. So yeah, that's congruent to that and that's congruent to that, but they don't all have to be congruent to each other, okay? Not all four of them. But with a rhombus, this is the cool extra. For a rhombus, the diagonals don't just bisect each other like all parallelograms, but they're perpendicular. Every rhombus has diagonals that create 4 right angles in the center. That's cool. All right, so let's see what we can do with that. I haven't looked at this yet, so this could be fun. So they want angles 1, 2, 3, and 4, and they've given us one angle. Okay, so let's think of all the other angles that we could get. So remember, this is a rhombus. A rhombus is a parallelogram. A parallelogram, by definition, has 2 sets of opposite sides that are parallel. So those are parallel and congruent. These are parallel and congruent. So 2 parallel lines crossed by a transversal alternate interior angles are congruent. So that immediately tells me that this angle is 53 degrees. Guess what? There's one more super cool thing about the diagonals of a rhombus. Okay, so super cool things about diagonals of a rhombus. Okay, the first super cool thing on top of everything else that just goes with every parallelogram, like the fact that they bisect each other, is they are perpendicular. And the second thing is they bisect not just each other's line segments, but they bisect opposite angles. Right? So if this is a rhombus, then this angle just got cut in half, and so did its opposite angle. Okay? So opposite angles get cut in half by a diagonal. So that means that if this is 53, this is 53. Isn't that cool? Right? So we got alternate interior angles here again, 53 to 53. So I know angle 3. Okay? We already knew angle 2. Okay? Now what about angles 1 and 4? Well, angles 1 and 4 are alternate interior angles, but we don't know either one of them. Wouldn't it be nice if we had a triangle where we knew 2 out of the 3 angles, so that we could just say, I'm going to subtract from 180? Oh, that would be so great. Well, this is 53, and we know this angle. It's 90 degrees. It's awesome. So 53 and 90, subtract from 180, so you should get 37 degrees. Okay, so 180, subtract 90, subtract 53, or just subtract 143. It's 37 degrees. So 37 degrees here. So if this is 37, this is 37, and then alternate interior, this is 37, this is 37. So 1 is 37, 4 is 37. Done. Okay, told you rhombi were cool. Or some people call them rhombuses. Yeah. Okay, conditions for quadrilaterals. So we've already gone over what needs to be proven for something to be a parallelogram. What needs to be proven for something to be a quadrilateral? Okay, has sides that are only line segments, no arcs, no curves, and it's closed. So, you know, that's 3 sides. It's not a triangle, it's not a polygon, because this side does not have both of its endpoints connecting to other sides. Okay? That right there means it's open. Okay, so that's not a polygon. So what does it have to give you to be a quadrilateral? 4 sides, and it's got to be a closed figure with line segments. Okay, so all of these are quadrilaterals, obviously. So you've got, the first one's quadrilateral. They all have 4 sides. They're line segments. They're polygons. Right? Rectangles or parallelograms. Well, let's go with parallelograms. Do they have, okay, let's go back to that list. Ways to prove that they're parallelograms right there. Do they have one of those 5 things? Do they have 2 sets of parallel sides, 2 sets of congruent sides, opposite sides that are congruent, 2 sets of opposite angles that are congruent? Do the diagonals bisect each other? Or do you have 1 set of opposite sides that are both parallel and congruent? Well, let's look. Congruent, congruent. That's parallelogram. Parallel, parallel. That's parallelogram. Opposite angles congruent, opposite angles congruent. Parallelogram. Okay, so now the last thing is rectangle. Can we prove that we have 4 right angles? So if this is said rhombus, I need 4 congruent sides. Rectangle, 4 congruent angles. What if it said square? I'd need 4 congruent sides and 4 right angles, okay? So is this a rectangle? It doesn't tell me about the angles. This may be slightly slanted. I don't know. That's not a rectangle, at least not that I know of. Look at this little sweetie pie. There's a right angle. Well, what did we say about 2 parallel lines and a transversal? Okay, consecutive interior angles, this guy and this guy, have to add up to 180. So if this guy's 90, that guy's 90. How do I know? Because of the parallel marks. Okay, so I know that I got 2 perpendicular marks here. So what about, let's go with these guys and this one. Okay, so consecutive interior angles have to add up to 180. So guess what? That's 90 degrees as well. How about this guy? Well, those are consecutive interior angles, so 90 degrees here as well. So if you've got a parallelogram, okay, and this may be an easier way to think about it too. We already said this is a parallelogram, right? So if it's a parallelogram, opposite angles are congruent. So if that's 90, opposite of it is 90. Consecutive angles have to add up to 180 because they're consecutive interior angles. So 180 minus 90 is going to be 90 again. And then opposite angles are congruent. So yes, this is a rectangle. There's plenty of information. Are all 4 of these angles congruent? We don't know. So that means we can't say that it's a rectangle. This is my only rectangle. Okay, I believe we hit the end of the line. Yes, we did. Okay, that's it for day 2. See ya.